Today we are going to start with the section we have started from yesterday. We studied the new topic, that is the intersection of a straight line with circles. So we are going to identify the points of intersection of a straight line with circle. It's a common factor, not only only a circle for whatever the curve or a straight line. We use the same strategy. Intersection of a circle with straight line. Straight line, that's a factor we are going to discuss. So we start from the first example over here. That is, we need to find the intersection of y equals to x plus 5. It's a one straight line with the curve x squared minus x squared plus y minus 2 squared equals to 29. So these are the two circles where we have to identify the intersection of the straight lines. Yeah, we're just going to start. So what you need to do is, if you want to find the intersection between those two straight lines, the basic technique we use, but it's not only for straight line with a circle, whatever the two straight line or two curves or curve with a straight line or whatever, you solve them as simultaneous equation. Here, this is one is a power equation and other is just a linear equation. We use the method of substitution to do it. So what you can do is, instead of this y, I can replace this x plus y because y is subjected over here. So we write substitute y equals to x plus 5 in equation number 2. So we can write this is x squared plus, instead of y, you can put x plus y minus 2 squared is equals to 29. That you can say x squared plus this is x plus 3, all things squared is equals to 29. Anyway, we have to solve this. You can say x squared plus 6x plus 9, bring this minus 29 to other side as a minus, turn up to 2x squared plus 6x minus 20 is equals to 0. Now you can say all the terms are divisible by 2. This is for just a simplification, minus 10 equals to 0, right? Then what you can get here is that if you simplify this, x plus 5 into x minus 2 equals to 0, that is x equals to minus 5 and x equals to 2, right? So there are two intersections, this straight line with this, the circle, right? Then we'll try to find out the y value, right? From 1, you can say y equals to x plus 5. There with that it's turned up into minus, if you put minus 5 plus 5, y equals to 0. From here you get the answer minus 5, 0 is a 1 coordinate, and the other one is y equals to 2 plus 5. So y equals to 7. So it's turned up to 2 comma 7. It's the next factor of it. So that is how you need to find the intersection of the this circle y equals to x plus 5 with y squared plus x minus 2 squared equals to 29 circle. That's a way of doing it, right? Okay. Right. Then let's try to understand how it is supposed to do a question somewhere like this. If you come up to this example, show that the line y equals to x minus 7 does not meet the circle x plus 2 squared plus y squared plus 33. That means it does not make any intersection, but we use the same technique for that. So the two lines are y equals to x minus 7 and other circle is, x squared plus y, x plus 2 squared. So it should be x plus 2 squared plus y squared equals to 33. Yes. Yeah, that's it. Right. Okay. Then how do you supposed to solve this matter? So we are using the same technique. Initially, we assume that these two meet each other. If you need to find the intersections of the this circle with the straight line, if it intersects, we suppose that we intersect, because later on only we can show that it does not intersect, right? Okay. We have to solve them as simultaneous equations. So you can say substitute y equals to x minus 7 in second equation. So you can say x plus 2 squared plus x minus 7 squared is equals to 33. So if you simplify this, you be getting the answer x squared plus 4x plus 4 plus x squared minus 14x plus 49. Bring this 33 to other side. Minus 33 equals to 0. Right? With that, you can say 2x squared minus 10x. So this is 49, 53. It's plus 20 is equals to 0. So if you simplify, x squared minus 5x plus 10 is equals to 0. Now what we need to do is we have to solve this as a, sorry, we have to solve this quadratic equation. Now they initially they mentioned that it does not meet in, this does not meet each other. So what we can get here is that if this quadratic equation do not have any solutions, we can say that it does not meet each other. How do you say that it does not, what do you call no solutions for this? We know that one solution, two solution, no solutions, those facts are related with the test what you are using is a test of discriminant. Okay? So you can apply the test of discriminant. Test of discriminant. So you can say b squared minus 4ac. Let's get this answer. So it's turned up into minus 5 whole thing squared minus 4a is 1c is 10. So it's turned up to minus 15, which is less than 0. Therefore, no solutions exist. Actually, this is no real solutions, but not just writing. The solution exists for x squared minus 5x plus 10 equals to 0. You can say therefore y equals to x minus 7 does not meet x plus 2 squared plus y squared equals to 33, right? That's a first optional method. There's a the second way of doing it. Suppose that if you forget this test of discriminant method, so I can start the question from here. I just try to find out the solutions for x. X equals to minus 5 plus or minus b squared. B squared is minus 5 squared minus 4a is 1. It's 10 divided by 2 times of 1. So we can write x equals to 5 plus or minus square root of minus 15 divided by 2. So you can say there is, it does not exist. Then after that you can say, again come up to this step. You can say that since square root of minus 15 does not exist, so if you put the calculator, you get the math error. That means you can say there are no roots exist for this kind of a question. Okay, but then the next extension type of a question they ask is this kind of things. Show that the line x plus y equals to 11 has only one intersection, meet a circle with equation x squared plus y minus 3 squared equals to 32 only at one point. That's how it comes. So just like this is x squared plus y plus 3 squared is equals to 32 at a one point. So what we need to get here is we have to show that it has only one intersection. Anyway, when you're discussing about the intersection, we have to solve these two equations as simultaneous equations, usual approach for this. So we just get from one, we subject one variable. We'll just subject x. I think that's kind of easier for me to do it. So you can say x equals to 11 minus y. Then you can say substitute x equals to 11 minus y in second equation. That's how we have to do it with it. Okay, right. Let's go ahead with this. Right. Then you can say this is 11 minus y whole thing squared plus y plus 3 whole thing squared equals to 32. So now let's try to simplify this. If I expand this bracket, it will turn up to 121 minus 22y plus y squared plus this is y squared plus 6y plus 9 minus 32 is equals to 0. So y squared plus y squared is 2y squared minus 22 plus 6 is minus 16y. Then 121 plus 9 minus 32. So when you do this calculation, do it much carefully because sometimes if you made some kind of like calculation errors, you may not able to get the result what they expect. Plus 98 is equals to 0, right? Then what you need to do is there are two approaches where we can go to show that there is only one intersection. That means if it is one intersection, this equation should gain only one solution. So one solution is we had to work out in the test of discriminant. Check whether what is the value for minus b squared minus 4ac. Right. So we'll just get minus 16 squared minus 4. A is 2 and C is 98 and see whether what is this value. So if you just work out 16 squared minus 4 into 2 into 98. Is that 98? No, it's not 98. Yeah, maybe just let's see. Yeah, I think there may be a problem came across. This is 11, it's at 11 minus y. Yeah, 11 minus y, that is correct. So for this case, 121 minus 22 plus y square plus 6y plus 9 minus is that 30. Just check whether the question is correct. It's 32 and 11. Yeah, it's 32. So it's turned up to 121 plus 9 minus 32 minus 32. It's 98. We just work out. We will see with 16 squared minus yes, where we made the mistake. This is let's see the let's check the question. X squared plus y minus 3. This is y plus 3. This is here the mistake is it's not plus 3, it should be minus 3. So and this is minus 3. Then we have to do small changes. It's minus 6. If it is minus 6, it's turn up into this way. Then minus 28. 22 minus 6 is minus 28. Now it will come minus 28. This should be minus 28. It's 28. Then you can say 28 squared minus 4 into 2 into 98. That is turned up to 0. So obviously you can say b squared minus 4ac is equals to 0 means you can write only one solution. So you can say only one solution. That means but only one intersection. Only one intersection. Okay. Then yeah, then that is the first approach, and the second approach is that is the answer for the second question also comes with that find the coordinates of point of intersection. So what you can do is after this point we can use the second approach anyway, whatever it's fine, so you can find the answer for y. Y is equals to minus 28 minus 28 plus or minus b squared minus 28 whole thing squared minus 4a is 2 and c is 98 divided by 2a divided by 2 into 2. So it's done up to y equals to, you get only 1 point. You get only y equals to 7. Because this part is anyway 0. Then you can say y equals to 7. Then you can write, sorry, x is equals to, from here, 11 minus 7, that is x equals to 4. So you can say it means at only this point. So you can say 4, 7 is the only intersection. Intersection. So like that even you can do this question. That's a way of getting the solutions for that kind of a question, right? Okay. Right. Then they mention here The line x plus y equals to a meet the circle x minus p squared plus y minus 6 squared at 310, where a, b are the constant. Work out the value for a and work out the two possible values of p. Right. Okay, let's go ahead with that. So they mention it meets at 310. So just the equations are x plus y equals to a. And the other equation is this way: x minus p squared, x minus p squared plus y minus 6 squared is equals to 20. Yeah, that one. So it meets at 310. This is 20. Then we need to find the value for this a and p. So you can say anyway, this equation is this equation travel to this point. So you can say x plus y equals to a. That means you can say this is 3 plus 10 should be equals to 8 because it satisfies this equation because both lines are traveling through that. So equals to 30. And the second case is from here. So you can say that's the first part of it. Then you can write 3 minus p squared plus y is 10. 10 minus 6 squared is equals to 20. So you can say 3 minus p squared, don't expand it. So we can just try to find some kind of a solution over here. Plus this is 4 is 16 is equals to 20. Then what you can get? You can write 3 minus p squared is equals to 4. That is 3 minus p equals to plus or minus square root of 4. With this you can write 3 minus p equals to 4. Therefore, p is equals to minus 1. Other one is 3 minus p equals to minus 4. Therefore, p is equals to 7. Right. So these are the two solutions of p. Right. Okay. After that, what you need to find is work out the possible value for b. That's all we need to find. Right. Okay. Right. If you move to the second question, the question number 9. Yeah. Yes. Then if you come up to this one, the circle, the equation x minus 4 squared equals plus y plus 7 squared equals to 50 meet a straight line, meets a straight line with equation x minus y minus 5 equals to 0, right? Then find the coordinates of point A and B. You have to solve them as simultaneous equation and you can get it. Then after that, what they request is find the equation of perpendicular bisect of line AB. We will try to work out how to get that answer. Then the next part is show that the perpendicular bisect of AB passes through the center of the circle. That's the second part of it. Find the area of the triangle OAB. Right. Initially, let's try to work out this question. Right. Yeah. Now, if you refer into this question today, the equation of the circle is this way: x minus 4 squared plus y plus 7 squared is equals to 50. That's my first equation. I'll get this. Then meet the straight line x minus y minus 5. X minus y minus 5 is equals to 0. Point A and B. Okay. Then initially, I'll just get this one as second equation. Then I'll subject y in equation number 2. So I can say y equals, if I brought it y to this side, x minus 5. Then you can substitute in equation number 1. So I can say x minus 4 squared plus x minus 5 plus 7 squared is equals to 50. Okay, then what you can get here is, then you have to expand it to the x squared minus 8x plus 16, and this is plus x squared plus 2 is 4x plus 4 minus 50 brought to other side and simplified. Yeah. Right. Then we'll simplify this. You can say 2x squared minus 4x 16 plus 4 is 20. 20 minus 50 is minus 30 equals to 0. By you can solve this values plus you can say x equals to minus 4 plus or minus b squared minus 4a is 2 and c is minus 30 divided by 2a 2 into 2. So from here you can get the answer for x. Let's turn up to 2 minus 4 and minus 30. One answer is 5 and other answer is 3. This is 5 and other answer is minus 3. Right? Then what you can get here is, then we can find the value for y. I can use this part of it to find the value for y because it's already y is subjected over here. So you can say y is equals to 5 minus 5. Therefore, y equals to 0. Other one is y equals to minus 3 minus 5, y equals to minus 8. Then you can get the two coordinates just like this. One coordinate is 5, 0. Other coordinate is minus 3 minus 8. You can find it as A and B. There is no priority for this much. So this is it. Right. Then we know these 2 points. Yes. Then one point is 5, 0. There is no prominent because there is nothing you can specially say this is A and this is B. So B is minus 3 minus 8. So there's a chord over here. Then what you need to find here is the next part of the question is find the equation of the perpendicular bisect of AB. So what do you mean by this perpendicular bisector means it's just like this. It's traveled through the bisector and perpendicular to that. So initially I can find the coordinate of M. M is the midpoint of AB. It is called perpendicular bisector. Midpoint of AB. So that is, you can say M is equals to 5 minus 3 is 2. 2 divided by 2 is 1. 0 minus 8 is minus 8. It's minus 4. M is minus 4. Then we already found the value for this and you have to find the perpendicular bisector equation with that. Then we know that it traveling through this much and you have to find the gradient. Without find the gradient, we know that if I get the line L, L is perpendicular to AB. Then how do you get it? So initially I try to find out gradient of AB. Gradient of AB is minus 8 minus 0 divided by minus 3 minus 5. So it's done up to minus 8 over minus 8 is minus 1. Then you can say, since these two lines are perpendicular to each other, gradient of AB into gradient of L should be minus 1. So with this, minus 1 into gradient of L is minus 1. So gradient of L become 1. Right? Then we can put in the formula y minus y naught is equal to gradient times of x minus x naught, right? Okay. So it's turn up to y minus y naught. Y naught is minus minus 4. It's this point. Gradient is 1. X minus x naught is 1. So you can say y plus 4 is equals to x minus 1. So with that you can say y equals to x minus 5. So I'll be very carefully simplify this. So if you made any mistake, you can't show the next next one as well. So again, yeah, this bit show that the perpendicular bisector will passes to origin of the circle. Right? That means you have to show that it passes to origin of the circle. Initially, we need to find the origin of this circle. So you can say, I will do it over here. Origin of circle. The equation of the circle is this. So what you can understand is equation of the circle is x minus 4 squared plus y plus 7 squared is equals to 50. Then from here we know that center O. O is 4 from here and minus 7. Right. We have to show that it satisfies this equation. This what? So you can say Have we made any mistake over here? Yes. Plus 4 minus 5. So the center is according to this much 4 and 4 and minus 7. So this way, let's see whether we did it perfectly. The midpoint is minus 3 plus 5 plus 2 plus 2 divided with this bit minus 8 minus 4, and the gradient is minus 8 divided by minus is minus 5 is minus 1. Its gradient is 1 minus 1 is 4, and it's minus x naught. X naught is 1. Minus 1 minus 1 is minus 5. That is correct. So we have to check whether our calculations are correct. Other than that, you might just minus 4. It's the other one is you can see, because if you make a mistake, you have to find out from the beginning where you made the mistake. So x is equals to y plus y equals to x minus 1. Sorry, x minus 4. So if you make any problem here, you have to see whether you done write the question properly. So like the question is properly written, it's not a problem. X minus 4 squared plus y plus 7 squared equals to 50. And yes, yx minus y minus 5. Then if you just made it, you can say y equals to x minus 5. So here it's turned up to x minus 4 squared, x minus 5 plus 7 squared is equals to 50. This is 16. This is plus 2. 4x plus 4 minus 50, x squared plus x squared is 2x squared minus 8x plus this is minus 4x, 16, 20, it's minus 30. So if you just put into this answer, the values what you obtain is 2 minus 4 and minus 30. One x is 5 and other one is minus 3. That is correct. So if I put 5 here, 5 minus 5 is 0. If I put minus 3 here, minus 8. Yeah, right. Then 5 minus 3. 5, 0 and minus 3 minus 8. 5, 0. If you just get them, the perpendicular bisect is a midpoint of this 5 minus 3. It's 2. 2 divided by 2 is 1. 0 minus 0 plus 8 is the midpoint is minus 8, it is minus 4. So it's a perpendicular bisector. The gradient is minus 8 minus 0 divided by minus 3 minus 5. Minus 8 divided by minus 8 is minus 1. So the gradient of the other line is 1. Then 1 minus y naught equals to gradient times of x minus x naught. X naught is minus 1. 4, it's minus 5 up to here, it's correct. So we have to, what they ask you to show that is, show the perpendicular bisector passes to the center of the circle. To show it's traveling to the center of the circle, it should satisfy this, this coordinate. Circle is x minus 4 and y plus 7 equals to 50. It's 4 and minus 7, then you can substitute over here. Minus 7 is equals to minus 4 minus 5. Minus 5. It's too much. Let me see where we made the mistake. Yes, but here's the problem. So you can just, yeah, I just made a mistake here, plus 1. So it should be plus 1 and this is minus 1. So this is minus 1. So it's turned up to minus 1 plus 1. If you brought it here plus 4, it's turned up to minus 4. It's minus 3. So it's turned up to here. It's turned up to then minus 3, then minus 7 equals to minus 7. With that, what you can get here is that therefore the perpendicular bisector travels to origin. So therefore, it travels through origin. So you'll be very careful about when you do the calculation sometimes. With hurry, when you do it, if you made a mistake, it's a little bit hard for us to understand the place where we made the mistake. So you'll be a little bit careful with that, right? Then the next one is find the area of the triangle OAB, right? Okay, let's see how to get this answer. So according to this one, okay, from this circle, we knew these coordinates. So I think we have already drawn this diagram. So we will use the same thing. And we need to find the area over here. The center is, according to this one, 4 minus 7. We need to find the area over here. How do you find this area over here, Pratik? And do we have any fact to get this answer? Yes. Then we know that here, we know these two coordinates. We know these two coordinates and we know these two coordinates, right? Initially, this is, you can say this triangle is a right angle triangle here. It forms a right angle triangle here. So if I use these coordinates just like this, no need of this diagram. So I just consider these points. O is 4 minus 7 and this B is, we already knew this answer, minus 3 minus 8, minus 3 minus 8, and this M point we already gotten as 1 minus 4, right? Okay. 1 minus 4, right? Okay. Then this is right angle triangle. Initially, we can find the length of OM. How to find the length of OM? You can say 4 minus 1 squared plus minus 7 minus minus 4 is plus 4 squared, the square root of it. From here, you can get it. 4 minus 1 is 3. 3 squared is 9. It's 9. And 4, say minus 4, minus 7 plus 4, so minus is 9, square root of 18. Square root of 18 is 3 root 2. Then we can get the length of MB. MB is, you can say, 1 minus minus 3 is plus 3 squared plus minus 4 minus minus 8 is minus 4 minus minus 8 is plus 8 squared. That is equals to then 4 squared plus 4 squared. It's 4 root 2, right? Now you can say area of this triangle is half base. Base is 3 root 2 into 4 root 2. That become 12. So there are two such triangles are there. Therefore, the total area of AOB become twice of this. It's turned up to 24. That would be the final answer for this kind of a question. Okay.